Music theory with Microsoft Excel. Hertz versus hue, mapping to a circle. In other words, we've mapped our pitch onto a circle. Now we're going to be mapping color onto a circle. So we can use the circle as an analogy for color and for musical pitch. So get ready and some coffee, because you ain't never seen rockin' unless you excel at rockin', and you need Microsoft Excel for that. Or in Excel, if you don't have access to this workbook, that's okay, because we basically built this from a blank worksheet but started in a prior presentation. So if you want to build this entire worksheet from a blank sheet, you could begin back there, or just build the part of the worksheet that we're currently working on. If you do have access to this workbook, though, 5 tabs down below. We've got the hex tab, the fretboard tab, which is very colorful. We'll talk about why shortly. We've got the example tab, in essence, the answer key, the practice tab, having pre-formatted cells so you can practice the practice problem with less Excel formatting. But if you don't have any of that, that's okay, because we'll be continuing work in the blank tab, where we started from scratch with a blank worksheet, continuing to work, in essence, in the blank part of the worksheet, practicing not only our music skills, but also our Excel formatting skills for formatting's sake. Let's go on over to the fretboard tab to get a reminder of what we are doing. Noting, I know this is very colorful here. We can tone down the colors when we're using this in practice, but the idea is to be able to maximally use a color system to map out onto our fretboard as an analogy, making our practice sessions, more efficient. Most of the time when we use color, we just kind of assign a random color to whatever we're working with, such as the scale that we are on, or possibly the tonic in the third. That's great, but we could be much more systematic with it, mapping the actual color wheel onto the pitch wheel, so that we have a color system that we can always associate, meaning we'll have the same color all the time for each of the notes. And it can kind of represent the distance between the colors, representing the distance between the pitches, which we can get into what that means kind of later. But that's going to be the general idea. We can also then have colors that blend together as we think about the idea of like intervals, which are kind of like the average or log average of the colors. So I know this is a little bit overwhelming, particularly when we go over on this side. We could tone it down. We'll talk about how to do that later. But the general idea is, if you wanted to tone this down and just look at like a few of these colors that we're going to be focusing in on, you could go in here and go to conditional formatting, manage the rules, and then we could delete some of these. And I just want to delete the ones. I'm not going to worry about it, because I can say okay, and now I'm just focused in on these notes. What if I want to return back to all of them? I could just pull the conditional formatting from here, format paint it, and I can put that back to where we were, which is great. And then all the notes here, we're measuring them by note. Each note has an individual color. So if I change this from the key of C, which is represented by 4, to a D, which is represented by 6, then the colors are changing. If I go to an 8, which is the E major, something's wrong with that one, but I'm not going to worry about that right now. Let's go to 9, right? So the colors are basically changing. Now you might say, hey, look, I don't want the colors to change, because I want to see the pattern as it moves as I go through the keys. In that case, let's go back to 4, C major. We could use this color system. So I'm going to use it based on the kind of like the Nashville number system, and I can use that. And you might say, well, that's the same. It is if you're in the key of C, but now you can see from like this position, if I go from the A to the I, and I change this from the C major, 7 notes from the C major, 4 to 5, you can see now that position has moved up here. So there it is here. And then if I change this to a 6, boom, then now it's been moved up here. So now we have the same colors moving up. This is a different color scheme now than the absolute note color schemes, right? I could say, if I want to see all the notes have their absolute color, I can go back to this one and look at it this way. So there's a lot of implications we can have with this, but the colors are representing something a little bit more specific than what most people would do with the colors. Now, to do that, we're mapping the color wheel onto the pitch wheel, which isn't exactly a perfect one-to-one match. It's more of like an analogy. And a lot of times if you look this stuff up on like the internet, people are going to come up with all these different kind of theories. So I think I've done a little bit more in-depth work on this than a lot of the stuff you'll see out there. So bear with me on that. All right. So the example tab, what we did before is we mapped out basically our hertz. Now the hertz represent basically the measurement that we use to measure pitch, which is what we're then going to pick from to pick our 12 notes in the musical alphabet, representing like a sine wave. You can think of how many times it jiggles, and that's how you come up with our hertz measurement. So we use that to kind of derive our circle, which we then broke down into 12 positions around in a circle using what we call a logarithmic system, meaning we took the spectrum within an octave, bent it into a circle in essence by pushing it into 360 degrees, and then we picked 12 of those notes. Now with the color, we could do the same thing. That's what we'll do this time. And now the problem is that color doesn't have the same characteristics as sound. How do we measure color? We measure color by length of the color. So the longer and shorter of the color is what we perceive as color. So I think they call those nanometers. So I don't know how they do it, how you measure color in the lab with a nanometer, but they do it somehow. And what they end up with is a range of colors that's going up in a range. So we have the same kind of idea with pitch, except that pitch has a characteristic that it actually kind of repeats to our ear, where color doesn't. It's just a spectrum. So that means we could do the same thing to color. We can bend it into a circle using a logarithmic system the same way. And so we'll do that to show that. And then we have an analogy of color to pitch, but only in one octave. So how can I get another octave representation in color? We can add that 3D dimension with another characteristic of color using like brightness or lightness. And brightness represents how close it is to white light, whereas as light, or is that right? No, light, yeah, that's what brightness is. And then lightness is how close it is to black, basically. So you can kind of mix it to go black. And that's good. So we'll use that to add the other dimension. Now, once we bend the spectrum into a circle, then the problem is it doesn't blend properly. The end of the spectrum doesn't blend into the start because it doesn't do that circle thing. We want it to do that. So what the system that's called an HSL, like over here, this is the hex. Once we bend it into a circle, then you'll see a spectrum that looks like this, but then they kind of cheat. So there's an HLS and an HSV system, which is basically taking the log average, and you can see the spectrum here is going down. And then when you get to like right here, now it's saying, the system is saying, hey, look, I want this to blend back into the red that we started with. So instead of it having this abrupt change like it would if we just did the log average, we just bended it into a circle, it fudges it. It puts this, what we call magenta, which isn't actually in the spectrum, but it's a nice blending thing. So from when we get to 300 all the way up to here, and now this red that's at the end of the circle that we're used to seeing isn't really correct. It's trying to just blend back into the proper red so that we get to the real point of the spectrum, which starts at 0 degrees. Okay, so what we're gonna do, I'm gonna kind of mathematically show how we can use the normal measurement of light, bend it into a circle logarithmically, which we could convert into color, which would have an analogy similar to pitch, in that the colors would represent like a distance and wavelength that would be similar to the distance in pitch distance. But it doesn't work as nice in our analogy as this fudged system, which is the reason they fudged it, adding magenta to make the circle work, because then you get that circular nature, which music actually has. So when we map it on the fretboard, we want to have that circular nature to it, because when we look at the notes on the fretboard, what's kind of interesting is the ones that are closer together often have more tension to them. So we actually want the colors that are further apart oftentimes. Those are going to be the ones that are going to go together better musically. And that could be represented with the color wheel that's kind of fudged with the magenta to the red. Okay, so hopefully that makes sense. I'll show you. Hopefully that makes some sense. So we're going to go over here. Let's go to the blank tab and just do it. So we started here with now we're going to go over to the wavelengths over here and do the same thing we did with the Hertz on the wavelength. So I'm going to make a skinny. Grab this one. We're going to format paint that over here, and we'll make a skinny. And so I'm going to say this is going to be the wavelength for light wavelengths. And so we're looking at visible light. I'm going to give us the units, and how do we measure the visible? We measure it in nanometers. So this is the visible spectrum, visible in nanometers. I think that's how we measure. That's the length of the light, which somehow they're able to measure, which is crazy. How in the world? I don't know. So we're gonna say, but basically, if you ask ChatGTP, is the starting and ending point of the visible light spectrum measured in nanometers? You're typically going to get a starting point of 380 nanometers, measuring the length of the light in nanometers, an ending point of either 700 or possibly 750. The problem being, human beings have a range of their capacity to be able to visualize the light above in this upper zone. I'm going to use the lower of the upper zones, the 700, because that's the part that most people can basically see. So I'm going to go from 380 to the 700. Let's say we go just nanometer by nanometer. So 380, we could say, let's just type in 381. I'm going to select these two, and I'm going to go down till I get to 700, which is the ending point of the length of light measured in nanometers that human beings can basically still detect. So I'm going to go on down. That's the spectrum that we're going to want to convert into a circle. Now, if I want to convert that into a circle, I need basically 360 units. What's the distance in units between these? If I start at 1, 2, let's count them. If I go nanometer by nanometer and I count these up, we're going to get to 321. So we don't have enough units this time. So in this case, what I'd like to do is stretch this sequence out. So you might say, well, why don't I use the 750, right? It's not going to, the problem is, it's not going to come out to exactly 360. So we're going to use the same kind of concept to kind of expand this so we have equal spacing of these measurements that will basically be within the 360, which will allow us to map it into, in essence, a circle. That's going to be what we're doing. So let's make this black and white up top. Home tab, font group, we'll make that black, and then white. And then I'm going to select this whole thing, Control Shift down, and let's make this blue. If you don't have that blue, it's in the more colors, and I like to go to that blue right there. And then let's go and make that bordered. Let's make this a different color just so we know that we're doing a different thing. We're on the light stuff, which will make dark blue. Selecting these two up top, double clicking to make them thinner, as thin as possible. That's still not very thin. Let's pull this one in. I can make that one thinner. All right, I'm gonna make a skinny. We'll grab this one, home tab, clipboard, paintbrush, make that a skinny. Now, if I did equal spacing to mirror what the first instinct would be to just space this thing out, I want 12 colors, in other words, to map onto my 12 notes. So the first thing we think about is like, well, what if I just make this, I'm gonna make this black and white, take my total NM nanometer units, How many of them are there? We said there was, let's go to the max tab, and this one, Control Shift down, there's 321. So we had 321 units. So if I want 12 of them to map onto the notes, I could say just divide by 12, and that would give me then a distance of 321 divided by 12. Okay, that's great, but it doesn't and that's actually even. No, it's not even. So it's not even, and it doesn't map exactly onto a circle in the same kind of fashion. So we'd like to have it out of 360 instead of using the equal spacing concept. So, but let's just map this out. If I did use the equal spacing, what would it look like? Just to see the analogy to what we did on the music side. So we're gonna say, all right, let's make a skinny over here. Format paint, skinny BA. It's a skinny BA. We're gonna say this is gonna be equal spacing again. And we have the notes, the units, and then the nanometers, and then, so that's what we'll do. And let's make this blue. Let's make it dark blue and bordered. I'll make these centered. And then I want 12 of them because I want to map them onto the 12 notes. So it'd be 1, 2. We'll copy that down to 12. To 12. And then the units, we're going to start the units at 0. So I'm just going to start at 0 and then pick equal spacing up. Now I want to round this up to 27 though. So I want to take the last part plus this, boom, but I want this rounded. So if I add decimals here, let's double click on this one. How do I round it? I could say round that second one to comma 0 to a whole number. Boom. So now we're going to round it. Why do I want it rounded? Because I want to pick the distance here and then pull the equivalent nanometer units. So I'm going to copy that down. There's still a problem though because I need to absolute. So let's delete that. I'm going to go on to it again. This one over here, I want to make it absolute. That's going to be AZ. So I'm going to F4 on the keyboard, $ before the letter and the number, enter. And then I can copy it down. Test it out. Looks correct. MUI B to the N. BN, baby. All right. So there we have it. So now we have the equal spacing. So now I just want to find those numbers over here and give me the nanometers. What's the nanometer distance? Because the nanometers would give me the light, which would give me the color. So I can convert the nanometers into the color. So I can then say, okay, this, I'm going to say equals X lookup. Well, actually, the first one is just going to be, it is what it is. I'm just going to say the first one starts at 380. And then I'm going to say this is X lookup tab. I want to find that 27 over here, comma. I want to find it in this array, comma. So we want to find that 27 in this array, and then I want to return this number. Control Shift down, okay, and then let's bring that back up. Boom. Pull this down. All right. So there it is. So we want to find that 27 over here. Enter. So 27 is right here. It should give me a 406. That's what it did. Let's double click. I don't want these to move down when I copy it down. I do want that to move down. Therefore, these need to be F4'd, or in other words, absolute reference. F4, 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 enter. Double click the fill handle, copy it down. So there's the nanometer. So here we have our equivalent of 12 notes. The nanometer equivalent. The nanometer is going to be the thing that we could then use to get the color. But normally we don't choose color by nanometer because we have to use one of the systems that are provided to us. Now, Excel usually uses the hex system, but we can also use, see we have the HLS system and the HSV system. And we have, but we could ask ChatGTP to convert these nanometers into HEX. I'm not going to do that because I don't want to spend too much time on this like analogy item here. What I want to do is convert this into the HLS system, which is a little bit fudged, as we saw, doesn't exactly tie into the logarithmic. We'll talk about that in a second. But that's what we could do there. But that would be equal spacing, and I want to do the analogy of logarithmic spacing so that I can then have the analogy of the equal spacing around the circle and then map that onto the pitch wheel. So I'll make this blue and bordered. So let's do it again and say, what if I did it with the logarithmic spacing? So let me get my cheat sheet over here because it's in the wrong order. I'm going to make this skinny. Let's make another skinny over here. And so now we're going to say, okay, this time I'm going to do, this is the degrees in a circle. Degrees in a circle. And this is going to be the incremental nanometers. Incremental nanometers. Okay, we're basically going to use the log idea. I'm going to say, let's make this black, white, and then center it. So in a circle, you have 0, 1. So I'm going to pull these, and it goes to 360 degrees. So I want 360 degrees. I don't want just the 12 notes. I want all 360, which I can then tie on to the 360. And you might say, why don't I just look for the 12? Because I would like to have things like to show a color for the average, which would be like the color equivalent of an interval and stuff. I'm going to make this blue instead of black. So what I need to do is take this one had units of 320. I want to give me 360. I want to expand this to make it into like a circle. All right, so how can I do that? So instead of taking each of these and expanding them, each one of them, what you do is you start on the first one and you give your formula kind of mapping out like a circle, right? So we're going to say, I'm going to start at 380 at that point and then say times 2, because we're going to kind of map it onto the idea that when it doubles, that's when it ends, and the pitch, that's when it repeats from a pitch side. I'm going to say to the power of, which is a caret, and we're going to say brackets, and then we're going to take the degree. We're taking 360 degrees in the circle. We're going to start at the 0 degree divided by the number of degrees in a circle, 360. Close that up and enter. I'm going to double click on it again. This first one, that 380, I want it to remain the same. Therefore, F4 on the keyboard, $ before the letter and the number. This one I want to move down. So I'm going to say, okay, copy it down one time, test it, double click. That moved down. That stayed the same. Let's copy it down, double click, boom. So now I have a system that gives me a measurement for 360 units, which maps beautifully onto a circle. So that's going to be the logarithmic numbers. Now that would be great. This, you can imagine, takes kind of like the color spectrum, which is just a line, right? And it puts it into a circle. The problem is that the spectrum would have a abrupt ending to it, because the end of the spectrum doesn't go back to red, right? So it doesn't blend back to red properly. So I won't actually map this out. You could ask ChatGPT, take these numbers in nanometers and convert it to an HLS or an HSV or a hex system, so that you can then come up with your wavelengths based on that. And you'll get a spectrum. My assumption is you get a spectrum that kind of would be going down to like around here, right? But that's a little different than what actually happens with the HLS system. What does this system do? It fudges it a little bit, right? So this is basically what the HLS system is doing. It kind of took the logarithmic average like we're doing here, but then it fudged the bottom because it starts at red, and then it doesn't want to end abruptly at like blue, you know? So it adds magenta into the, so it adds, it adds this magenta into it, so it forces it back into the red. So that actually works great for our analogy, although it's not exactly the logarithmic system of converting the linear system into a circle. So, bottom line, you could convert this directly into a circle, but I think our analogy actually works better with the fudged system that they use that kind of blends the end in. So I'll show you what I mean. But first let's make this blue. Let's make this blue. Control Shift down. I'll make this bordered and blue. Okay. So we have our equal spacing. Let's make this skinny over here. I'll take that skinny and put that here. So now we have our logarithmic spacing. So I'm going to say this is going to be, we'll call this the logarithmic spacing that we would like is going to be then the total units in a circle, or the degrees in a circle, we could call it, is going to be 360. And then we're going to divide that by 12 to get our 12 colors that are going to represent the notes, our typical notes. And then the distance is going to be equal to 360 over 12. So we get that same 30. So I'm going to then, same that we got when we did the pitch. So I'm going to make this blue and white. I'll make this blue, the lighter blue and border. A fly is distracting me. A home tab, it's a gnat. It's not even a fly, it's a gnat. I'll take that gnat out. If it was a fly, it's a little too fast for me to get it, but I can take out a gnat. They're slow, they're stupid. Let's make this logarithmic spacing. So now we have the notes and then units that we're going to be pulling in. And this time, instead of calling it, you could say it's nanometers. So I could say like, this is nanometers, but really I'm gonna kind of cheat here and convert it to HLS. So I'm just gonna say this would be the nanometers if you wanted to look it up, but I'm actually gonna just use the HLS system, which did what we're doing here, except it fudged the end of it so it has that nice blend in at the end, so it goes back to red. So it put in the magenta to the rose or whatever. All right, so then we're gonna say then this will be blue and bordered. Let's say blue bordered. Let's make this centered, and we've got 12 notes. 1, 2, copy, format, paint that down. 12 notes. Okay, and so then the units we want are going to be once again starting at 0. And then it's going to be spaced out by 30. So it's going to be that 0 plus 30. I don't need to have a rounding system because that's an even number. So I'm going to say F4 on the keyboard, $ before the letter and the number. Copy that down. So we've got 30, 60, 90, 120. I'm just going to find these distances, these even distances in the 360 degrees that we have mapped out to the spectrum of nanometer measurements. So let's go on over here and say, all right, equals X lookup, find that 0, comma, in the 360 degrees, comma, and then I want you to return to me the nanometer distance, which I can convert to a color, which I'm going to do this time with the HLS system. So it's 380. Double click. I want these two ranges not to move down. So I'm going to F4, $ before the letter and the number. F4, 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 F4 for the ranges. Not for that one though, because I want that one to move down. Okay. And then copy it down, double check it. Looks good. So now I have this number. Now again, I could call this the nanometer, right? And I could ask Excel, give me these 12 units in nanometer, measured in nanometer. And I'll get something a little bit different than what we're going to use, which is to measure this in HLS, which again fudged the circle wheel as far as I can in the end of it. But this actually works great for us because it does mirror what music does pitch-wise. So I'm just going to say that I'm just going to use the HSL system right over here. So now we've got the HLS system, not the HSL. You dyslexic son of... Okay, it's backwards. Get over it. You know what I meant. I'm going to say, then we have the notes. So then we can have the notes, which are going to be equal. Let's just copy the notes we did over here. So here's the notes. And then I can copy that down. So boom. So now these are the colors that are going to represent these notes. And so that's great. And so now we're going to say boom, black, white. And then I also, as we learn this, you can learn patterns like the whole, half, whole, half. Now we can see it by note name. We can see it by color. I'm also experimenting, and I saw this idea. I wish I remembered the guy's name I saw it on, that was playing with shapes. And I think that's really good as well. So I'm going to actually add these shape names. So I'm just going to copy and paste these from my cheat sheet. And I'm going to tell you how can you get that if you don't have this cheat sheet. You can ask ChatGPT to give you Excel shapes that represent squares and circles. And then you could just copy and paste from ChatGPT or whatever your favorite system is, AI system, onto Excel. That's the easiest way to do it. Or, and then it'll give you like a list of shapes that you can copy. Now these, I think, are working nicely. Why is this useful? It's kind of nice if you look at like the whole half formula. You can see that formula by shape if we label every other half step with either a circle or square, or a filled in circle versus a non-filled in square here, filled in versus not filled in, because then you're going to end up with a shape that will be either circle, 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 square, 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 because there's going to be a whole step between the like shapes and a half step between, or you'll end up with a square, 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 circle, 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 circle. See how you can see those patterns? So that's another way you can see it. You can do the same thing if you numbered the notes by seeing even and odds. So whatever note you start on, if you apply the formula whole half, you'll end up with even number, odd, and then odd, or odd number, even. Same thing, right? So from my perspective, the more ways that you see the pattern, then that is going to connect more neurons in your brain. That's the definition of understanding something better, is to be able to see it from multiple perspectives. At least that's a definition I'm working on. So we're going to say this is black, white, and centered. Okay, so now now the problem is that I can't use these numbers for Excel. So now what I would do is I ask ChatGPT, hey, give me the HEX numbers based on these HLS numbers, right? And if I ask ChatGPT, I won't do it right here, but I'll just show you. It's going to give me this numbering system. So now I have an HEX numbering system. So in other words, we derive the logarithmic system from the range, which is kind of what the HLS system does, but then we convert it to the HLS system, which basically has 360 units, but it kind of fudges the end of it to map it on. And then we converted using ChatGPT, asking ChatGPT, hey, here are the units from an HLS system. Convert that for us, please, to an HEX system. And you can even ask ChatGPT, please give me the numbers and format the cells, and give me an Excel worksheet that shows me these cells with the number in it, which you have formatted with that color. So in other words, if I go into this color system, I can manage the rules, or I can go into here and say format the cell. Let's do it this way. I can go into this color up here, color the cell, custom color. There's the code, FF0000. Now this code takes into consideration all of the dimensions. So basically the hex system kind of makes sense because it's mainly, you can kind of think of it, I think of it as like hue, the hue color, but there's also brightness and lightness. So the next step would be, well, what I need to do is mirror what would happen if I was on, I'm going to imagine this is our first round of octave. I'm in one octave. I could go an octave up and an octave down. How can I use color to show the octave up and an octave down? Because the color range, if I look at just hue, doesn't have that. I can't just measure the length of light because it only has the range. But I could add another dimension, which could be either lightness or brightness, right? I'm going to use lightness, which is basically saying how close the color is to black, right? So it can make the color darker. Basically, you can think of it as like adding black to it or not. And that can give us a shade of the color. So if I go an octave up, what I'm going to do is I can't do it mathematically like I can in Hertz. I can say 440 is the lower octave, 880 is the higher octave. That's going to be 2 A's, but I can see it in the pitch range. I can't use the equivalent here saying here's the nanometers and double the nanometers. But what I can do is just say if I go an octave up, I'm just going to layer on top of that we have a darker color. So the way I would do this is ask ChatGPT, here's the lightness, which is going to be represented as 0.5 lightness, not brightness. 0.5 gives you the brightest colors in brightness. So we asked ChatGPT to convert with a 0.5 to give us these bright ones. Then I'm gonna go down to 5 to a 0.3. So I'm gonna ask, now convert these or give me these same hue colors, but make the brightness go down from a 0.5 to a 0.3, I believe is what I said. And so now it's going to give me these series of numbers. Now the numbers don't really make any sense. We're kind of dependent on ChatGPT, but you could see what happened here is it gave me a number now that basically converts it down. Now you can do the conversion yourself if you want to. Like you can say, this is the HLS and use a converter online to convert it so you can at least double check some of these numbers, right? You can convert it to the HEX system. To do that, normally to get the brightest color, you're going to make the lightness 0.5. And then if I convert this same thing to the HEX system, but I want to make it darker, then I'm going to change it to a 0.2, I think, 5 or 3. And then it'll return the HEX number. The HEX number has everything in it. It has lightness. So there's a different number for all of them, but we can't really conceptualize how they did it logically in our mind. You can just imagine a massive table that takes into account hue as well as brightness and lightness. Okay. So so then if I make the brightness go the other way, so now I'm going to make it brighter, which I think, so now I'm taking this same color. I'm saying, okay, convert this ChatGPT or using your color converter to the HEX system from an HLS to the HEX number. But now give me the lightness, which I think I went the other way. Instead of going higher, and higher is closer to black, so I went lower to go bright. I forget which way goes which way. Closer. But that's the general idea. So you can kind of tinker with that with the conversion tool or ChatGPT and test it out, right? If you convert the HLS with a 0.5 lightness, you'll get to that. If I go 2 units down from a 0.5 to a 0.3, or 2 units up from a 0.5 to a 6.7, I'll get these 2 brightnesses. So now the reason that's useful is I can map this on. So now I have a 3-dimensional spiral staircase. I can represent all A's as just this red, but I could on my fretboard say, look, I want to represent the higher numbers looking different. So I can see the difference between the A's, like a C4 versus a C5 should be a lighter color, right? And so I can kind of see that, or C3 should be a darker color. So this will give you another added dimension to it if we want to use that added dimension. So this is where all the options come in on the fretboard. So we can now look at the fretboard with standard colors, or I can look at the fretboard with colors that are mapped out that are always the same depending on mode. Or I could look at the fretboard where the colors are going to be different in shade as we go from like a C4 to a C5 or a C3. And so see how all those things could be a useful tool. And I can look at the fretboard in a way that I can see numbers for even and odds looking at the pattern that way, and look at the fretboard with the shapes. So I can look at the pattern for circle, 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 square, 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 right? So if I look at this fretboard, I can map this fretboard out with multiple different colors. I can look at the shapes here, like here's the C, it's a square, whole step, well, let's go down here, square, whole step to a square, whole step to a square, 3 squares, half step to a circle, and then we go circle goes I can't see the circle here, I gotta make that one, goes whole step to a circle, whole step to a circle, whole step to a circle, right? So it's right, 3 shapes, 1, 2, 3, and then 4, circle, 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 circle. And see how that makes it a little easier if you're looking at this shape in multiple strings. You can see it by circles and squares. You can see it evens and odds, right? This is having, right, if I start here, we start on an even note number 4, which is going to be the C, even, 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 and then it switches to odd, 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 odd. And of course, we can see it by color, and we can map those colors onto our color system, having each note with a unique color, or we can use a system where we're going to have all of the modes have a color that will be the same as we go through basically different modes. Now note the goal here isn't to say, okay, which of those systems work best for me and then always work in that system. I think the goal would be to say, well, which system works best for me so I can at least start to learn that system. But then I'd like to be able to see it using as many different formats as I can, right? I'd like to be able to see the same thing by shape, see the same thing by chord construction, see the same thing by even and odd numbers, see the same thing by color, see the same thing by circles versus squares versus filled in shapes versus non-filled in shapes. See the pattern. The more different ways you can see the pattern, the better, right? That's the game, right? You want to be able to see the pattern backwards and forwards, multiple different ways with different tools, all the different ways you can see it, the better your mind will make more connections, and the better you'll grasp all of the different ways. That's my theory.